Hello everybody and welcome to the YouTube channel of the Professor Lahoussine Haji. I will give you in this video the first video in English, and we talk about the nuclear reaction, and especially we talk about the fission nuclear reactor. So I will give you gradually the solution of this problem. Donc, we give the mass of proton, the mass of nuclear, the mass of uranium nuclear, and the mass of the krypton, the mass of barium, and the molar mass, Avogadro number, and 1 MeV in joules. So, the first question, provoked nuclear reaction. As a result of collision with a thermal neutron, a uranium 35 nuclear undergoes the following reaction. Okay, the first question is to compute y and z in this equation. So, to find y and z, we can use the two conservation of the number of the charge number and conservation of the mass number. Donc, the first equation we can give as 0 plus 92 equal 36 plus z plus 0. So we can find z equal 56. Conservation of the mass number, 1 plus 235 equal 19 plus 142 plus y. So we can find easily y equal 4. This is the first question. Okay. Donc, the second question is to indicate the type provoked nuclear reaction of this type. What is the type of this reaction? As you see, this reaction is what is the fission nuclear reaction. Fission nuclear reaction. So, next, calculate in MeV the energy liberated by this reaction. So, the energy liberated is equal what? Delta M dot CO square 2. And this is equal delta M in unity the mass atomic dot 931.5 mega MeV. So if we, of course, delta M is equal mass of krypton plus mass of barium plus 3 mass of neutron minus mass of uranium. And you can find 169.253 MeV. This is the energy liberated by this equation. So now we said that in fact only 7% of this energy appears as a kinetic energy of all produced neutron. Before to do the next question, let's first compute 7% of of the energy liberated. This is equal 7% dot 169.253. Okay, and we said that this energy is determine the speed. Now we said determine the speed of each neutron, knowing that they have equal kinetic energy. So this is the total kinetic energy. Okay, 7% of appears energy liberated appears in as a kinetic energy. So the total kinetic energy equal this number. how many neutron this reaction liberated? It liberated 4 neutrons. So the kinetic energy of 1 neutron, the kinetic energy is equal total kinetic energy over 4. Okay, and this kinetic energy is equal in joule. We must translate 1 mega electron volt in joule. Okay, and you can find kinetic energy in joule is equal 4.739.10 square minus 13 joules. Okay, this is kinetic energy of 1 neutron. Or kinetic energy is equal 1 over 2 mv square 2. And we can find the speed of 1 neutron is equal square root of 2 dot kinetic energy over mass of 1 neutron, of course. And if you compute this value, you can find a speed equal 2.379.10 square 7 meter per second. Okay. Now, a thermal neutron that can provoke nuclear fission must have a speed of few kilometers per second. Or we found in kilometer per second, this is in meter per second. So in kilometer per second, we can compute this is equal 30,719 kilometer over second. It's very large than 1 kilometer per second. So we need to indicate that the role of moderator. The moderator is to reduce this energy. A moderator will help us to in reducing the speed of this neutron. Okay, the speed of neutron, because the neutron liberated with a speed very, very large than few kilometers per second. So the next question is, in a nuclear reactor with uranium, the average energy liberated by the fission of one nucleo is 170 MeV. Determine in joule the average energy liberated by the fission of 1 kilogram of uranium. So this is energy 117 MeV. This energy liberated just by one nucleus. Okay, so we can first compute the number of nuclei in 1 kilogram. This number is equal, of course, the mass over molar mass dot Avogadro number. So, of course, you can 1 kilogram is 1000 gram over molar mass each equal 230 uranium 35 dot Avogadro number, which equals 6.02 dot 10 over 33, and this you can find the number of nuclei is 2.5617 dot 10 over 44 nuclei. This is the number of nuclei in 1 kilogram of uranium. So the next question is the nuclear power of such a reactor is 1 megawatt. Calculate the time needed so that the reactor consumes 1 kilogram of uranium. In how many days or how many hours this reactor can consume 1 kilogram of uranium. Okay, so we know that the energy is equal the power dot delta T. We know the power liberated by one nucleo. We know the number of nuclear in 1 kilogram of uranium, so we can calculate easily delta T is the total energy liberated over the power. And the total energy liberated is equal excuse. Okay, donc we said we checked we calculate the time needed to consume 1 kilogram, and we have the energy is equal to power dot delta T, and delta T is the energy liberated by 1 kilogram over the power. We know the number of nuclear in 1 kilogram. We know the energy liberated by 1 nucleo. So the total energy liberated by 1 kilogram is the number of nucleo dot the energy liberated by one nucleo is 117 dot in joule. We must multiply by 1.610 over minus 30. And the power is equal the 100 megawatts, so 10 over 8 watt. So we can find delta T is equal 8 day. So, okay. The next is to study the activity of uranium. Donc, uranium is an alpha emitter. Derive the expression of Ln of I in terms of initial activity lambda and T. We know that the activity is equal A0 exponential minus lambda T. So Ln de A equal Ln de A0 minus lambda T. The adjacent figure represents the variation of Ln de A of a sample of uranium as a function of time. So, show that the shape of the graph is in the adjacent figure agrees with the expression of Ln de A. Well, what we have Ln de A equal Ln de A0 minus lambda T. That is, it means that Y is equal a constant A minus Bx. It is the equation of line with a slope of minus lambda. So this equation or this figure is agree with this equation. D'accord? Now we can, using this adjacent figure, determine in second minus 1 the value of radioactive constant lambda. So we said that minus lambda is what? Is the slope of this line. Let's compute the slope. The slope of this line. The slope is equal 12.29 minus 8.15 over what? Over 1, but don't forget 10 over 17 seconds. So this is equal to, donc equal to what? Donc to call 3.14.10 over minus 17 seconds minus 1. So at the end, derive the value of radioactive period. We know that lambda equal Ln2 over T, so the period is equal Ln2 over lambda. This is, you can find in seconds 22.0747.10 over 15 seconds, which equals 7.3 10 over 8 joules. It's very, very, very large. So, okay, this is the first problem in English. I hope it's clear. So, so at the end, thanks for watching this video and subscribe to my channel. See you later in the next video.